All right, well, hello. This is chapter 12, section 1, organizing data using matrices. Our learning objectives are to organize data in a matrix and to add and subtract matrices and multiply a matrix by a scalar. Now, don't be frightened by the word matrix because it is not such a scary thing. So here's our vocabulary for this section. A matrix is a rectangular arrangement of numbers in rows and columns. More than one matrix is a matrices. So, for example, we have the Agawas and the Bakers, and then we've arranged these in columns, which are the up and down guys, like support columns, and in rows, which are across. An element is each item in the matrix is an element. A scalar is a real number used for a special purpose, and in this section we're going to use it to multiply a matrix. Bringing us to scalar multiplication. It's an operation that multiplies a matrix by a scalar. Scalar is a real number. So you multiply each element in the matrix by your scalar. So when you look here, our scalar here is 2.5. What's going to happen is each item is going to be multiplied by the 2.5. So we got 1 times 2.5, 0 times 2.5, negative 2 times 2.5, and 3 times 2.5. The resulting products are then your simplified matrix. All right, so let's do some stuff with matrices. We are going to add and subtract them. And what we do is when you are adding them, you take the matching elements, so in this case I'm adding, and you add each element to its matching element in the other matrix. So in this case it would be negative 5 plus negative 3. And then you got 2.7 plus negative 3.9. And then we have 7 plus negative 4. And then we have negative 3 plus 2. And then the resulting matrices is what you get when you do those additions. It's the same with subtracting. So in this case, 2 and negative 1 would be subtracted. 11 and 8 would be subtracted. Negative 4 and negative 6.5 are subtracted. 3.2 and 4 subtracted. 1.5 and 0, and negative 5 and negative 3. If you are terrible with integers, because this has a lot of minus a negative and plus a negative, all that stuff, feel free to use a calculator. So then you do 2 minus negative 1 is 2 plus 1, which is 3. 11 minus 8 is 3. Negative 4 minus negative 6.5 is like negative 4 plus 6.5, which is 2.5. And so on and so forth. So we get all of our items. So let's see how we would do that here. So my operation is plus, so I have 5 plus negative 9, which is negative 4. I have 3.2 plus negative 1.7. So that is like 3.2 minus 1.7. And that's 5, 1.5. So you just go straight across. And then I got negative 4.9 plus negative 11.1. And that will give us 6, negative 16. So we have negative 4, 1.5, and negative 16. All right, so let's look at B. So for B, I'm going to do each, so I'm going to move B down here. Each element is going to be subtracted from its matching one. So I'm going to go negative 4 minus negative 5. I'm going to go 0 minus negative 1. I'm going to go 3 minus 0.5. All right, and then we have 3 minus 0.5, and then we should have 7 minus negative 3. And then we simplify all that down. Negative 4 plus 5 is 1. 0 plus 1 is 1. 3 minus 0.5 is 2.5. And 7 plus 3 is 10. And that's how we do. All right, let's look at that scalar multiplication we did earlier. Easy peasy. All we got to do is take the element and each element and multiply it by the scalar. So the resulting matrix will be negative 2 times negative 3, negative 2 times 7.1, and negative 2 times 5. So when you do the math on that, that is 6, negative 14.2, and negative 10. It's the same when you have a larger matrix. It's as if every element gets a little 1.5. So when you do this multiplication, you get 1.5 times negative 11, and that would be negative 11 plus 5.5, which is 16.5. 3 times a 1.5 is 3 plus 1.5 is 4.5. This one is easy. 1.5 times 0, and 1.5 times negative 1.5 is negative 2.25. Okay, so let's take a look at how we're going to use matrices. So use the weather chart below. Which city has the greatest average number of clear days in a full year? Average number of clear and cloudy days, September through February. Phoenix, 102 clear, 41 cloudy. Miami, 43 clear, 58 cloudy. Portland, 55 clear, 82 cloudy. March through August, Phoenix, 110 clear, 27 cloudy. Miami, 31 clear, 59 cloudy. Portland, 45 clear, 83 cloudy. So here's each of those cities. So we're going to use matrices to organize the information. So identify the city in our time frame range. We organize them with clear and cloudy. Do the same thing with March through August, clear and cloudy. We are going to add the matrices to find the average number of clear and cloudy days in a full year for the city. The matrices are the same size, so we can add them straight across. So if you notice, that's Phoenix plus Phoenix equals total Phoenix clear. Phoenix cloudy plus Phoenix cloudy equals total Phoenix cloudy, etc., etc. So now we're going to find the greatest average number of clear days in a full year, and that's our, if you look at, here's our clear column, and our biggest number is 212. All right, so look at that same problem. Which city in problem 3 has the greatest average number of cloudy days? Cloudies are in this column. And the one that has the most in the right-hand column is 165, and that would make Portland the winner. So go ahead and type Portland right here. Done. All right, and that's it for this